Chapter 3 taught us everything we need to know about how to find a derivative, how to calculate a derivative. And a derivative is a special function that tells us the slope anywhere along the original function. Chapter 4 is all about what can you do now that you know how to find derivatives. So your 4.2 handout was fine just the way it is. There are two parts to your 4.2 handout. You have one part. It was at one point I told you to cross it out and make it 4.3. It's really 4.2. So 4.2, properties of functions. What do you know about a function based on what you know about its derivative? So remember, if derivative means slope, let's say that's uphill to you, right? So if I tried to find the derivative of this function, the slope of this function is positive because this function goes uphill as you read it from left to right. So if the derivative of a function is positive, then the original function must have been increasing. Similarly, this function decreases, it goes downhill. If I tried to find its derivative would have to be negative. The derivative of a decreasing function is negative. So on your paper here, not orange, okay, if f of x is continuous on some interval, a to b, if f prime is positive on that interval, then f is increasing. Thank you for your patience as we develop handwriting technology for tablets. Is increasing on the interval a to b. Notice that a comma b, that's an interval. Those are both x values. That is not an ordered pair. The words we use, it's on an interval or at a point. But when we talk about where a function is increasing or decreasing, it's increasing on whole intervals at a time. So, and if f prime of x is negative, remember less than 0 means negative on a to b, then f of x is, you guessed it, decreasing. Thank you for having neater handwriting than this tablet on a to b. You just increased the percent of questions you can answer on the AP test by like at least 5, maybe 10%. It's a big question, comes up a lot. When is a function increasing? When is it decreasing? Definition that comes up sometimes, I want to be able to use it. A function is monotonic. So mono, you know from Mr. Morrison, right? Mono meaning one. It does one thing. Function is monotonic. It's either always increasing or always decreasing. Okay, so now that we know this is a big deal. If a function's derivative is positive on an interval, then that function must have been increasing. What can we do? We use it to analyze functions, and you'll see these kinds of examples. You'll see these problems all over the AP test, both the multiple choice and the free response. We'll do some examples now. All right, this example is definitely from your textbook. I'm not sure what an example number it is. So I copied these definitions over so that we can refer to them. Can you find all the values of x for which y equals x squared is increasing or decreasing? Now, I would expect that you could be able to think about a picture, y equals x squared, you know that guy, that's just the regular old mother parabola function, mother quadratic. And you could think about the graph, and I hope answer this question. The whole goal of calculus, the whole goal of chapter 3 and then chapter 4, is to be able to give an algebraic answer to this question. So when is a function increasing? A function is increasing anywhere its derivative is positive. So that's exactly what we're going to do. We're going to solve this inequality. Where is the derivative? Positive. And you're going to have to be able to make that connection. Positive means greater than 0. So this is my technique. I'm going to solve this inequality, which I hope you will not find distressful. dy dx is greater than 0. The derivative is positive. That's what I want to know. Cool. dy dx in this case is easy. That's 2x. I want 2x to be greater than 0. That's true anytime x is greater than 0. So I'm going to conclude that f of x is increasing on the interval from 0 to infinity. That's the same thing as saying x is greater than 0. So that's two different ways to write that interval. And then here is where you're doing calculus. You did calculus when you had to take the derivative, but that was easy. Your calculus shows when you give this reason. F of x is increasing on 0 to infinity because f prime of x is greater than 0 on that interval. This is the math way, the symbol way of saying the derivative is positive. So I would expect that 100 times in the next 5 months, you will write a statement that looks exactly like this. This interval will change because the problem will change and the numbers will change. But this is the form of your answer. F of x is increasing on this interval, in this case is 0 to infinity, because f prime of x is greater than 0 on that interval. A function is increasing where its derivative is positive. Notice you could also have said f of x is increasing when x is greater than 0 because, so this is just using the variable, this is using an inequality notation to give the same interval. We still want to be able to give an answer, and the wording changes slightly because f prime of x is, oops. You could say is positive there. I want you to form the habit of using symbols is greater than 0 there. So then the answer to the next question, where is y equals x squared decreasing? You probably know the answer. You could just find the complement of the answer to the first question, or we could go through the same process again. We could solve this inequality. I need the derivative to be negative. I need the derivative to be less than 0. So 2x is less than 0. I can solve that. I get x is less than 0. And I get f of x is decreasing on the interval negative infinity to 0 because f prime of x is negative on that interval. Here's the next example. I want to answer this question. Find all values of x for which y equals x cubed plus 3x squared minus 45x is increasing. And then once you figure that out, it's not too much work to figure out where that same function would be decreasing. So when you see this problem, and you will see it at least 100 times over the next couple of months, you will see it multiple times on the AP test. Where is a function increasing? Well, a function is increasing where its derivative is positive. So you have to be thinking in your head, I need y prime, if my function is supposed to be increasing, I need my y prime to be greater than 0. Once you know that that's your process, and you got a point if you just wrote this down. That's the calculus they're testing. They need you to know. They need to know that you know that a function is increasing where its derivative is positive. The next job is to, number 1, figure out the derivative, and number 2, figure out how to solve the inequality you end up with. Finding the derivative is a calculus question. Finding how to solve that inequality, that's like an algebra 2 or a pre-calculus question, depending on where you took your algebra 2 and your pre-calculus. If that's the part that you don't understand, and this next example I do, that's when I need you to go back and watch those prep for 4.2 videos. Remember, you just got a point for writing down that you know you have to have the derivative be positive. You'll probably get another point for figuring out that you need to take, or like correctly taking the derivative. That next part, you're definitely going to need to know how to do it, but it's not a calculus question, so it's a algebra pre-calculus review. Again, you can go watch those other videos I made. I called them prep for 4.2. All right, so we said we're going to solve y prime is greater than 0. Y prime, that's not the hard part in this problem. This is a polynomial function. To take its derivative, we're just using the power rule. So I have a new problem. My y prime, 3x squared plus 6x minus 45, I need that to be positive. So that's why I have is greater than 0 here. So this is a quadratic inequality. To solve it, I need 0 on one side. I'm going to factor to find the roots, and I make a sign chart. So again, if this is a little fuzzy to you, you want to go back and check out those videos I made. I called them prep for 4.2. So I'm going to factor. I notice there's a greatest common factor of 3, so that comes out first. Now x squared plus 2x minus 15. I'm going to factor that's x plus 5 times x minus 3. Once I've got the factored version of that polynomial, I can notice what the roots are. The roots are the x values that would make that polynomial on the left equal to 0. And it seems to me that they are 3 and -5. And I mark them on the number line. Remember, this is a degree 2 polynomial. The biggest exponent on x is 2. So it would be typical to find 2 roots. If I don't find 2 roots, that's fine. It's just some of the shortcuts I'm used to aren't as easy. So here I've marked a number line with my 2 roots, -5 and 3. Those 2 roots are going to split my number line into 3 sections, and each of those sections separately might give positive or negative results. I'm going to go back at the end. Since that says greater than 0, that means positive. I'm going to go back at the end and pick all the sections that end up being positive. So remember, we check this by letting x equal something from each of an x value from each of the sections on the number line. You might start with x equals -6. If you're at the point where you do this part in your head, that's fine. You don't have to show any of this work. If you're thinking this, well, 3x squared plus 6x minus 45 is a parabola with a positive leading coefficient. I know it opens up. It must go positive, negative, positive. You're totally right. That's what's going to happen. There's going to be more complicated functions in the future. So I'm going to show you this way to always make sure you have the right signs on your sign chart. So this 3, it's always a positive 3. It's not going to change the sign of my outcome. If I let x equal -6, that's going to be a -6 minus 3 is a negative. -6 plus 5 is also negative. Negative times a negative would give a positive result. Why did I put the plus sign over that section of the number line? Because this x value I started with is from that section of the number line. If I let x equal 0, because that's on the interval from -5 to 3, I'm going to end up with a negative times a positive, which will make a negative result. And if I pick something bigger, you can test it out. If I try 4, that's going to give me a positive times a positive, which would be positive. So the question, where is the function? Where is this function, x cubed plus 3x squared minus 45x, increasing? Well, it's increasing anywhere its derivative is positive. I'm sorry I didn't think to say this before, but can I strongly urge you, if you ever make one of these sign charts, tell me what function it's for. Oops, there's no f in this problem. My original function was y. I'm making a sign chart for y prime because I need to know where the derivative is positive or negative. So I'm going to label that as a sign chart for y prime. So I'm going to come to this conclusion that y is increasing on -infinity to -5 and 3 to infinity. Notice there are two sections that ended up positive because f prime of x, this is my video and my slide set, but that doesn't mean I don't find things I don't want to fix. I'm going to say because y prime is greater than 0. The thing I had written there said f prime, but there's no f in this problem, and I hadn't stopped to define f. I want to make sure I'm only using variables that are already defined. Because y prime is greater than 0, I'm going to say on those intervals. My original I had said on that interval. Technically that's two separate intervals, so I'm going to say on those intervals. So I don't even have to go through the same process to answer part B. I already have a sign chart for y prime. Y prime is negative on the interval -5 to 3, and I know that a function is decreasing where its derivative is negative. So I can jump right to this next part of the conclusion for part B. Whoops. Yeah, that wasn't the right slide. So if I wanted to write this up, there's my write-up. I would say y is decreasing on the interval -5 to 3 because y prime is less than 0 on that interval. The same way as it's the same thing as saying the derivative is negative. So this math part, a lot of great stuff here. I hope you enjoy solving quadratic inequalities. If you're not ready to make this statement because y prime is negative on that interval, then you're not ready for calculus. So make sure that when you're describing your work, you're going to be asked to give a reason for your answer or to justify your work. You have to have this solidly. This is probably the most important. Like, if you can't answer this one, you didn't prep for the AP test. The function y is decreasing on that interval because its derivative is negative there. So you'll notice there's a place for those same two statements from the top of this paper on your 19 facts paper.